Hello, children. Today we are going to study about the midpoint theorem and how does it, and we will do an experiment to verify it. So, the midpoint theorem states that the line segment connecting the midpoints of the two sides of a triangle is parallel to the third side and is congruent, meaning equal to one half of the third side. Now, let us see what we are going to verify here. We need to prove here that PQ is parallel to BC as well as PQ is half of BC. So we will do this experiment to see. Now here first of all what I need to do, I need to make a triangle and I will choose a scalene triangle because if it verifies the scalene triangle it will verify all other kind of triangle. So I'm going to select a side which will be even number. So the first side that I'm taking is at 4 centimeter. Second side I'm taking it as 6 centimeter, and third side I'm taking it as 8 centimeter. I'm doing this just so that for us it is easier for us to find out the midpoints of this. So we're gonna go and draw the triangle. Now here you can see my triangle has been made. A side AB is of 4 centimeter, side BC is of 6 centimeter, and side AC is of 8 centimeter. The next thing that we need to do is we need to gonna find out the midpoint of these sides. So as you can see, I've got the point P, which is the midpoint of AB, point Q, which is the midpoint of side AC, and point R, which is the midpoint of side BC. We will join these points to we will make a draw a line segment here. Now you can very clearly see I have joined. So basically we will need to prove here as per our theorem that PQ is parallel to BC and PQ will be half of BC. So we're gonna select a triangle here, that is triangle APQ and triangle QRC. If I can prove these two triangles congruent, that is triangle APQ is congruent to triangle QRC, then this will show that the distance between these two lines, that is PQ and BC, is equal. And if the distance between the two lines are equal, that means they will be parallel to each other. And to prove this congruent, I'm going to drag this yellow triangle and I'm going to overlap on this. If it overlaps it completely, that means these two triangles are congruent. So I have dragged this, and now you can very clearly see after dragging it from here to here that my triangle APQ is congruent to triangle QRC. And because these two triangles are congruent, that means my line PQ is parallel to my line BR. Now, next, what we need to do here is what we are good now, because these two triangles are congruent. That means by CPCTC, my PQ will be equal to my BR, right? Since my PQ is equals to BR, I'm going to write it here so that you all understand. PQ is equals to BR, and since R is the midpoint of BC, that means BR will be equal to RC, and I can write BC as BR plus RC, right? So in place of BR, as you can see, I can simply I'm going to use a different color here. So in place of BR, I can write PQ because BR is common. So in place of BR, you can very clearly see I can write PQ, as well as since BR is equals to RC and BR is equals to PQ. So in place of RC also, I can write it as PQ. So I can write PQ plus PQ. So this means that I'm going to use a darker color here. This proves that BQ, or I can say, let me just use an eraser. I can write PQ is equals to half of BC. And this proves our theorem that the side PQ, we have already proved that it will be parallel to BC, and we have also proved that PQ